So today, we're going to talk about the other trig functions. Okay, graphing the other trig functions. And so let's review a little bit. And you should have your pink sheet handy. Okay. So, first thing, let's review. Sine and cosine have a period of what?
2 pi.
2 pi.
Did you do this yesterday then?
Nope. This is brand new today.
Okay. For lesson 4.
Cosecant and secant. Now what's the relationship between sine and cosine, cosecant, secant?
They're flipped.
They're flipped. So basically remember, sine and cosecant are reciprocals. Cosine and secant are reciprocals. So since they're reciprocals, obviously you can imagine that they're going to have the same period. And the period will be 2 pi. Now tangent and cotangent, on the other hand, they're a little different. And I will tell you right now that instead of having a period of 2 pi, tangent and cotangent have a period of pi. So the first one was review, the sine and cosine. Cosecant and secant relate to those, so they are 2 pi. And then tangent and cotangent have a period of pi. And so now what we're going to do is we're going to go through the graphing of tangent. And so that's why your pink sheet should be really handy. Now I noticed that some of you kind of got some empty pink sheets. You kind of need to be working and getting those done. Okay. Those are going to be due next week. All right, so. So now, as I said, we're going to start by graphing tangents. So with your pink sheets, I've got a question on the next page. And I want you to go ahead and use your pink sheet to answer that. At what values is tangent undefined? So at what values is tangent undefined? So on your pink sheet, what do you see?
Pi over 2.
Pi over 2, good. So tangent is undefined at pi over 2?
3 pi over 2.
3 pi over 2, good job. So there we go. We see that tangent is undefined at pi over 2 and 3 pi over 2. Now just a little tidbit. We said before the period was pi, right? What is the difference between these two values? Pi. That's interesting. So the question is, how would we graph tangent now, especially when we have undefined values? And so what we're going to do is we're going to walk through how you graph tangent. Now notice, usually you have to graph 2 full periods. And so what I'm going to do here is I'm going to go ahead and start at 0, 0. And then I'm going to go ahead and work my way left to right, and then I will try to graph the left part of the graph. So the first thing I'm going to do, using your pink sheet, what is the tangent at 0? What's the tangent at 0? What is it? Tangent at 0 is 0. Now we said at pi over 2 it was undefined. So at pi over 2, if something's undefined, how do we graph that? How do we graph something that's undefined? Do we remember? Do you remember what that's called if I have a dashed line? Do you remember what that's called, a dashed line? Starts with an A. A dashed line, this is from chapter. Next letter is an S. Next letter is a Y. Next letter is an M. Next letter is a P. Asymptote. Asymptote. Okay, and so It's undefined at pi over 2. It's also undefined at 3 pi over 2. And so at 3 pi over 2, I'm also going to put a dashed line. So whenever something is undefined, we're going to put in an asymptote. And remember, an asymptote is similar to what? A barrier, an invisible boundary. And so now I need to figure out what is the graph doing between there. So, let's just pick some values. What would be a value between 0 and pi over 2? 1. Let's try 45. Okay, so pi over 4. What is your value on your sheet at pi over 4? Or 45 degrees? What's the tangent at that? Tangent at 45? Nope, close. Worst comes to worst, you've got your calculator, type it in. Tangent at 45. 1. Okay, so the tangent at 45 is 1. So that doesn't really tell me a whole lot. What about the tangent at 30? Let's try 30. What's the tangent at 30? Okay, root 3 over 3. What does that come out to be as a decimal? So that I kind of know where to plot it, since this is at 1. 0.57, so roughly a little over halfway. So let's pick another one. Let's pick a value between 45 and 90. What would be a value between 45 and 90? 60? Okay, so what's tangent at 60? What's that come out to be? Decimal? 1.73. So if 2 is up here, 1.73 is going to be roughly here. Okay? Alrighty, kind of getting a little picture. Let's try and figure out this area right here now. Okay, so I've got from 90 to 270. So let's pick a value between 90 and 270. So let's pick a value at 180, which would be 1 pi. What is the value at pi? Or 1 pi? 180. So what's the tangent of pi? 0.
How did your line curve go? That's
We haven't done anything yet. We haven't graphed anything yet.
your dots aren't straight line.
They aren't, no, they will not be straight line. Just hold on. We'll get there and all. Okay, so let's pick a value between 90 and 180. What would be a value between 90 and 180? 135. Okay, at 135, what is the value of tangent? Negative 1. Okay, so at 135, negative 1. Okay, let's pick a value between pi and 3 pi over 2. So let's pick, I don't know, 225. What is it at 225? Positive 1. Okay, now if you remember tangent, sine and cosine curves were curved. Tangent are curved as well, and so this kind of gives me a picture of what the graph is going to look like. This part of the graph is going to go up like that. Okay? Down here, this part of the graph is going to start and go like this. And so we've also got a left part of the graph. And a left part of the graph, I'm going to come here to negative pi over 2. And I'm going to go ahead and draw a dashed line in. And so, can somebody guess what that's going to look like? It's just going to go just like what the one before did. And so basically, tangent is just going to look like that, repeated over and over again, because if you remember, the period of tangent was pi. So here is one period right here. Here is another period right here. So I've graphed 2 full periods right there. So now we've looked at that. Now what we're going to do is we're going to look at how you would graph negative tangent of x. So what do you think the negative is going to do? What do you think the negative is going to do? Opposite way? So first of all, I know that tangent has an asymptote at pi over 2. I know that it has another asymptote at 3 pi over 2. I know that at 0, it is 0. So I also know that there is another asymptote at negative pi over 2. So if you remember the old tangent went low to high, what do you think this one's going to do? High to low. So it's just going to go this way, just like that. And this one, there's going to be a dot at pi right here, and it's going to go high to low. And there you go. So that's the graph of positive tangent, negative tangent. Questions? So now what we're going to do is we're going to look at what the tangent graph looks like. So there you go. That's what the tangent graph would look like on graphing software. Now what we're going to do is we're going to look at cotangent. Cotangent of x. So now this is where your pink sheet once again is going to come in handy. So at what values is cotangent undefined? So where's cotangent undefined? 0
Pi.
and pi. So basically it's kind of a flip. So at 0 you've got an asymptote. At pi we've got an asymptote. I would also have another asymptote at 2 pi. Because that's the same as 0. Now I just need to fill some values in. What would be a value between 0 and pi? Pi over 2, which would be like 90. What do you think the value is going to be right there on your graph? 0. Good. Okay, so now I need to figure out which way is it going to open. Okay, is it going to go high to low or low to high? And so in order to do that, I need to pick a value between 0 and 90. Between 0 and 90 would be pi over 4, or 45. So what is the cotangent there going to be? What's the cotangent of 45? 1. Good. So here's 1. So we can guess that our graph is going to look like what? Oops, that was bad. Let's try that one again. There we go. High to low.
So you don't actually have to keep doing points if you know.
Nope.
Like if you know what the actual design is and you've got 2 points, you can basically just figure it out.
Yep. So that's the graph of cotangent. Here's what it looks like on graphing software, real similar to what we just got done doing. Those vertical lines, remember, are asymptotes. And so then now, here's your graph of secant. Now the graph of secant is actually what's in green. So really, this blue isn't part of the secant graph. So if you look at the secant graph, what does it look like? U's and upside down U's. It's basically a bunch of parabolas. And so one period of the secant graph is 1 pi, 2 pi. So there you go. That's one period of the graph. Cosecant, same thing. U's and upside down U's, except for this one is located at different locations. So basically what you're going to need to do with cosecant and secant, you're going to need to figure out where is it undefined. So here you go. This is your assignment. Your assignment is to graph tangent, secant, cotangent, and cosecant. You identify the period and make sure you graph 2 full periods. That is your assignment for today. That is from this section in the book, and that's all we're going to be doing from this section.
Can you keep that up still for a little bit?